Hello, let's take a look at some quadratic functions and graphs. We've talked about these to some extent whenever we looked at basic functions and shiftings and reflections. We're going to continue this concept further and just delve into the topic a little bit more. So, just as I mentioned, we've discussed a basic quadratic function, f of x equals x squared, and its basic transformations, f of x is equal to a times x minus h squared plus k. So let's kind of review some things here. What does the value of a represent in this transformation? Yeah, a is a stretch factor or shrinking factor, if you will. What about h? Yeah, h is the horizontal shift, and k is the vertical shift. Now, a little bit more involved here. Do you remember reflections? If we have a negative on the inside, we reflect across the y-axis, but a negative on the outside reflects across the x-axis. And that would happen here if the value of a is less than 0. You're going to have a reflection as well as possibly a stretch or shrink depending on the value of a. Okay, so remember that f of x is equal to x squared is really that basic parabola that has a vertex at 0, 0 and going up. So our new vertex, we'll talk about that in just a minute, comes from that shifting of the h and the k, and the direction of the parabola comes from the a. So let's talk about how does f of x equals negative 3 times x plus 4 squared plus 1 compare to the graph of f of x is equal to x squared. So what would we have to do? What does x plus 4 do? Right, that is the horizontal shift, and remember it's not what we think it is. If it's plus 4 inside, it actually means that we have to go to the left 4. What about this negative? That's right, it's going to reflect over the x. The 3 says it's going to stretch by a factor of 3. And then what about this 1? Right, it will move up 1. So let's think about that. If we were originally at 0, 0, we go left 4. So we were kind of up here. But then we have to reflect, which lifts us down. And we're stretching by a factor of 3, which makes the graph skinny, but that's because all the values are increasing by a factor of 3. And then go up 1. So we're really at this point negative 4, 1, and looking something like this. Now I don't have the intercepts correct there, but just to get that general feel of the way the graph looks. Now that you kind of remember that, this is what we're going to do. In this section, we're going to look at a graph that's of the form ax squared plus bx plus c. That's still called a quadratic function. It's not in this kind of vertex form where we can shift it around, but we're going to be able to convert from this polynomial form, ax squared plus bx plus c, to this formula that will allow us to stretch and shift. And we're going to use completing the square to do that. Then we're going to identify the vertex of a parabola from both forms, graph quadratic functions, and state some key things about them, like the domain and range and other key points, and solve application problems. So let's first start with this objective of using completing the square to go from this polynomial form, ax squared plus bx plus c, to this vertex form, if you will. So some books call these a standard form and vertex form. Well, let me remind you what completing the square is all about. Completing the square only works when you're trying to create what we call perfect square trinomials. And what is the deal about perfect square trinomials? Like, for instance, x squared plus 6x plus 9 is a perfect square trinomial. And that is because when we look at the factored form, it's really x plus 3 times itself, or x plus 3 squared. So a perfect square trinomial is a trinomial that can be factored as some binomial squared. And notice that that's what's kind of housed inside this vertex form, and that's why we need that. What about x squared minus 14x plus 49? What is it in factored form? Yeah, that is x minus 7 times x minus 7, or x minus 7 squared. So some things to note. The sign on the middle term determines the sign that's in the polynomial. Now, what is true about this number that's inside the polynomial? How does, for instance, the 3 relate to the 9 and the 6? How does 7 relate to the 49 and 14? Three is half of 6, right? But 3 squared gives you 9. 7 is half of 14, and 14 squared is 49. So the way the constant works is that it is half of the middle coefficient. Okay, now I should say that's a constant in the binomial. Now, the last term of the trinomial is half of the middle coefficient squared. Okay, and finding that last number is actually the process of completing the square. So let's see here. What number would complete the square if we had x squared minus 8x? So you have to take half of 8, which is 4, and square it is 16. Now notice in a perfect square trinomial, the last sign is always positive. Well, to check it, that should factor as something times itself, which x squared minus 8x plus 16 is x minus 4 times itself, or x minus 4 squared. Now what about x squared plus 10x? Right, we would take half of 10 is 5. 5 squared is 25. To check, that factors as x plus 5 times itself, which is x plus 5 squared. So this is kind of a little piece of the puzzle for what you're going to have to do to go from this one form to the other form. Okay, but a very key part of the puzzle. So to complete the square, you're taking half of the middle coefficient and squaring it. So let me show you how it will apply to the quadratic functions here. So what we want to do is go from p of x, which is x squared minus 8x minus 10, to some form that is equivalent to that, that looks like this. So to do this, what we need to do is think about the x squared minus 8x as kind of a separate entity. The minus 10 right now is a problem, right? Because if we take half of 8 and square it, we don't get 10, right? Half of 8 squared is 16. So we need a 16 there, not that minus 10. So what we're going to do is kind of bring over that 10 on the other side of the equation for right now. And the way we do that is we have to add it. And now we're going to think about the number that would complete the square. So half of 8 squared is 16, like we just said. So what we're going to do is add the 16 to both sides. Okay. And now the next step, we're going to simplify on the left. So that's really p of x. And if you don't like that p of x, you can call it y. 10 plus 16 is plus 26. and that's equal to x minus 4 times x minus 4, or x minus 4 squared. Let me back up. I don't know if I iterated this really enough or emphasized it enough. Whenever we add the 16 on the right to make it a perfect square trinomial, we have to add it on the left to balance the equation. You remember the cardinal rule of equation solving is what you do to one side, you must do to the other side. So that is the reason that I added the 16 on both sides. I tell you right now that's a common mistake to forget to do, so make sure you're doing what you do to one side, you apply to the other. Now all we have to do is get it in this form where we have p of x on one side, so we can move that 26 over to make this p of x is equal to x minus 4 squared minus 26. Okay? So now we can see how this original equation really is a translation of the basic parabola by moving 4 units to the right and 26 down. Now, number 2, p of x is equal to x squared plus 6x. Maybe I should have started with that one because there's not anything hard or anything that I have to get rid of, right? Those two x terms on a side by themselves. So what I've got to do is think about, first off, what number will complete the square. So if I take half of 6 is 3, and 3 squared is 9. So what I add to one side, I must add to the other side. So this would give us p of x plus 9 is equal to what? How do I factor x squared plus 6x plus 9? Right, that is x plus 3 times x plus 3, or x plus 3 squared. So my final step is to get the p of x, or the y, on one side, and I can subtract 9. Okay? So these two things are equivalent. Understand that. I'm just rewriting one from that standard polynomial form to a vertex form, and that will allow me to easily identify like the vertex point, whether or not it opens or closes, the domain, the range, a whole lot of things that I can read off from that. Let's do one more. P of x is equal to 2x squared minus 2x minus 24. This one is a little bit different because if you notice, let me go back here, in the other problems, what has been significant about my coefficient of x squared? Right, it's understood to be a 1. Well, what happens if it's not a 1? If it's not a 1, I've got to divide through by that number. So what I would need to do, first off here, is divide everything through by 2. Okay, what makes this ugly sometimes is that that coefficient doesn't nicely divide the other terms, but it does happen to do so here. So I would get p of x over 2 is equal to what? X squared minus x minus 12. So now I need to get the terms for the x by themselves. So I'm going to have to subtract, well, actually not subtract, but add 12 to both sides. Okay. So I removed the constant. Now I've got to complete the square. So what number is, kind of tricky here, what's the coefficient of x? It is 1, right? So we have to take half of 1, which is 1/2, and square it, which would be 1/4. So we have to add 1/4 to each side. I know you're thinking, oh great, I just love these problems. But now I need to combine 12 and 1/4 together. 12 is actually, what, 48 over 4? Would you agree with that? Because 1 goes into 4 times, and 4 times 12 is 48. So we really have a 48 over 4 plus 1 over 4, which is going to be 49 over 4. And then on the right, we need to factor that. X squared minus x plus 1/4. Well, it's always x minus, or whatever the middle sign is, and then the number we squared In this case, we squared 1/2 to get 1/4, so that's what we need in the parentheses. So just a few more steps. So now we have to bring back over that 49 over 4. So we get p of x over 2 times x minus 1/2 squared minus 49 over 4. And then a last step, clear out the parentheses by multiplying by 2. So that would give us just p of x is equal to 2 times x minus 1/2 squared minus 2 times 49 over 4 is actually 49 over 2. Okay? So you're thinking, okay, I could pick up the calculator and graph it that way. But it is important to be able to know how to go from one form to the other. Okay. Now, the nice thing, once you know all of that form, identifying the vertex, which is our next objective, that's going to be staring you in the face. Because p of x equals a times x minus h squared plus k has a vertex of hk, right? We're going to shift by h to the right or left, and then move up or down by k. And that's exactly where we end up, is the vertex point, hk. Now, what about this? P of x equals ax squared plus bx plus c. You may think, hey, I don't want to go through that completing the square anymore. I just want to be able to get the vertex from that form. Well, you can, actually. There is a formula that will allow us to get the vertex when it's in this polynomial form. And it is derived by going through the completing the square process to that general polynomial form. Now, I don't expect you to memorize this process, but I do want you to understand where it came from. When we complete the square to this general form, we would have to apply those rules that we just talked about, where you have to divide through by the coefficient of x squared if it's not 1, which is where this p of x over a and all those come from. Then we have to remove this constant to the left. Then we have to take half of b over a. Half of b over a is b over 2a, and square it. That's where we get that b squared over 4a squared. So that's where that term gets added inside to complete the square. Then we can factor this, which is x minus b over 2a squared. Not minus, sorry about that, x plus. X plus b over 2a squared. So then we can combine those terms by getting a common denominator. Again, you don't have to know that, but that's where all this stuff came from. And then I moved that term over and then multiplied through by a. And so what that really tells us is that this value here and this value, though we never really memorize that, this value is going to be the x value of the vertex. In fact, just remember the opposite of what we have to do. So this is really a negative b over 2a and p of negative b over 2a. In other words, to find the vertex from this formula, if we know what a, b, and c are, really just a and b, we can get the x value of the vertex by plugging into negative b over 2a. Does that remind you of something? Anybody remember the quadratic formula? We're going to get into that in the next section. Yeah, there's a lot of similarity here. That negative b over 2a happens to be the x value of the vertex because it turns out that the vertex point is exactly in the middle of your two x-intercepts, which is what the quadratic formula actually tells you. Kind of getting ahead there, but that's where you see that negative b over 2a. And then p of negative b over 2a means once I find the x value, just plug in the x value into the function to find out what the y value is. Okay? So let's go through some problems here where we have to find out what's a vertex, and let's also talk about the direction of the parabola. So the first one, p of x equals the opposite of x minus 2 squared plus 4, it's already in that vertex form, so the vertex is going to be, what, shift right 2 and up 4, so that's going to be 2, 4. What about the direction? Right, that negative indicates a reflection over the x-axis, so that means that this parabola is going to open down. What about x squared plus 4x plus 5? Yeah, we could go through completing the square if you want, but we don't need to even do that. What we can do is find the x value of the vertex by looking at negative b over 2a, where a is 1 and b is 4. So we would have the opposite of 4 over 2 times 1, which is negative 4 over 2, or negative 2. Now that's only half of the vertex. To find the y value of the vertex, we have to plug negative 2 into the function. So we would have to work out negative 2 squared plus 4 times negative 2 plus 5. So that's going to be 4 minus 8 plus 5. 4 minus 8 is negative 4, plus 5 is 1. So that vertex point is negative 2, 1. Now what? Oh, and how does it open? Well, the coefficient of x squared, which is our value of a, is positive, right, and it's 1. So the parabola does not have to do a reflection over the x, it just opens up. What about p of x is equal to 2x squared minus x plus 3? Again, we don't want to go through that completing the square process to get it in the vertex form. We can simply find out what negative b over 2a is, where we find a is 2 and b is negative 1. So we would get the opposite of negative 1 over 2 times 2, which would be positive 1/4. So then we find y to be 2 times 1/4 squared minus 1/4 plus 3. So this is y is equal to 2 times 1/4 squared would be 1 over 16 minus 1/4 plus 3. Kind of ugly when you have fractions, but just plug it into the calculator if you need to. 2 times 1/16 would be 1/8. Minus 1/4, just kind of keep in mind we would have to get a common denominator. 1/4 is really 2 over 8. And 3 is the same thing as, what, 24 over 8? So really we find what? 1/8 minus 2/8 is negative 1/8, plus 24/8 would be 23/8. So the vertex point would be 1/4, 23/8. Now what about opening? Yeah, a is positive, so it's going to open up. Now let's talk about graphing a parabola. And I'm going to do these by hand initially, but I'll show you on the calculator video how you can certainly do that on the calculator. If you have x squared minus 2x plus 3, let's talk about first of all what would be the vertex point. Now the vertex we could find by doing negative b over 2a if you like. So x would be the opposite of negative 2 over 2 times 1, which is really 2 over 2 or 1. The y value of the vertex is going to be y is equal to, plug in 1 squared minus 2 times 1 plus 3. So 1 minus 2 plus 3. 1 minus 2 is negative 1 plus 3 is 2. So the vertex point is 1, 2. Now what about the domain? Do you remember the domain of a parabola? Right, the domain of a parabola is all real numbers. Right, there's nothing that we can't plug in for x. The graph of a parabola extends indefinitely from left to right. Now what about the range? Yeah, the range is dependent upon that vertex point, so we can't just say it's all real numbers. But what we do know is the general shape of the graph, right? We know that the vertex point is 1, 2. We know that by the fact that the vertex or the value of a is positive, it opens up. So the range would be from bottom up with the y value, so that's going to start at 2 to infinity. Now, a couple of other things about a parabola. If we follow the parabola along the vertex point, do you notice we get a mirror image of itself? That straight line, that vertical line through the vertex is called the axis of symmetry. Since it is an equation of a vertical line, it's always of the form x equals whatever the h value of the vertex is, or the x value of the vertex. So in this case, I can add another category here. If we wanted to find the axis of symmetry, we would have to write the equation, which is x equals 1, that goes down through the vertex. Now here's another thing. If you wanted to do this more accurately by hand, you can choose points to the left and points to the right of the vertex just to get a few more points to fill in. So if I wanted to, I could plug in a point to the left of the vertex would be 0. If we find p of 0, we would get 0 squared minus 2 times 0 plus 3, which is just 3. So we know the point 0, 3 lies on the graph. Now by virtue of the symmetry, that means if we go one unit to the right from the vertex, we would also have a point that's a mirror image that has a y value of 3. So we also know that 2, 3 would be on the graph. Now what about p of x is equal to negative x squared plus 2x plus 1? Well, if we find the vertex by doing negative b over 2a, we would get the opposite of 2 over 2 times negative 1, which is negative 2 over negative 2, which is 1. Didn't mean for that to happen, but I guess I wasn't paying attention to the numbers, but that's okay. The y value of the vertex, we have to be careful here. That is the opposite of 1 squared plus 2 times 1 plus 1. So we would get a negative 1 plus 2 plus 1. So negative 1 plus 2 is 1. 1 plus 1 is 2. So look at that. The vertex is the same thing. The domain is still negative infinity to infinity. Now what about the range? Yeah, this one's a little bit different. And that is because of what? Yeah, the negative sign on the coefficient of x squared is going to make the parabola flip down. And so what we would have to do is still go ahead and plot the parabola, or the vertex point. And when we do that, we get what? 1, 2. This time it's going to open down. If you want to get a few more points on there just to be pretty precise, you can. Like, let's plug in 0. P of 0 would be the opposite of 0 squared plus 2 times 0 plus 1, which is just simply 1. So we know 0, 1 is on the graph, which means also if we go out to the right of the vertex to 2, we should also find a mirror image point at 2, 1. So the parabola is going to look something like this. So the range is from bottom up, so that would be from negative infinity to the maximum y value, which is 2. Okay. You're going to have some application problems in here, and those application problems generally are going to ask you to find the maximum or minimum value. And anytime you see that dealing with a parabola, one thing that you should notice is the vertex point is either the smallest or lowest point in the graph or the highest, depending on the direction it opens. If the parabola opens up, that vertex point is a minimum point. If the parabola opens up, that vertex is a maximum point. And more importantly, the y value of the vertex is either the maximum function value or the minimum function value. Again, depending on which way it opens. So if it asks you to minimize something or maximize something, that should kind of connotate in your head, I've got to find the vertex. So let's look at a problem and then we'll be done with this video. It's to solve application problems, and the general application in here is dealing with the height of a projectile, though anything would work here. S of t is equal to negative 16t squared plus v sub 0 t plus s sub 0. T is time in seconds. S sub 0 is the initial height in feet, and v sub 0 is the initial velocity. This is a lot of times given to you, but just so you know the general form of that equation. That negative 16 has to do with the gravitational force on the Earth. So if a rock is projected upward from ground level at an initial velocity of 90 feet per second, how high will the rock be after 1 second? What is the maximum height? And when will the rock reach the ground? So a few things that we've got to answer. So let's think about our formula that we need. Our S of t was what? Negative 16 t squared plus v sub 0 t plus s sub 0. Well, what were we told? That it was launched from the ground, right? So from the ground means that its initial height is 0, and the initial velocity was 90 feet per second. So we can plug those in to get negative 16t squared plus 90t plus 0, which we don't need. So then we need to calculate how high will the rock be after 1 second. Well, after 1 second, t is our input, right? It's in seconds, so that's just asking us to plug in 1 into the function. So we would have negative 16 times 1 squared plus 90 times 1. So what is that? 1 squared is 1 times negative 16 is just negative 16 plus 90. So S of 1 would be what? 74. Okay, so that means that in 1 second, what were we launching? I can't even remember now. A rock. Okay. The rock will be 74 feet above the ground. Then it said to find the maximum height. To find the maximum height of the rock, we have to find the vertex. Well, there's two parts to the vertex, right? An x value and a y value. The x value is the time. The y value is the actual height. So we've got to find both of them to be able to answer the question. So we would find the x value, or t value, which is negative b over 2a in this case, which would be the opposite of 90 over 2 times negative 16. So what is that really equivalent to? 90 divided by 32, which is 2.8125. Okay, so it's going to take 2.8125 seconds for it to reach its maximum height. To find the actual maximum height, we've got to plug that number in. Definitely use a calculator to do this. And you know what? 2.8125 is some fraction. You could convert it on your calculator. Doesn't really matter. You can just keep it in that form. And I'm taking just a minute to compute the calculation. Okay, and I get 126.56 approximately. So we would say approximately 127 feet. So it takes 2.8 seconds to reach its maximum height of 127 feet. Okay. And then it says, when will it reach the ground? So to find out when it reaches the ground is what? What height is the ground? Yeah, the ground is at a height of 0. So what I've got to do is set negative 16t squared plus 90t equal to 0. Now we're going to talk more about quadratic equations and solving them later, but hopefully you remember this, that if there's a common factor, I can divide through by that, right? And is there a common factor between 16 and 90? Yeah, hopefully there is, right? Definitely 2 goes into it. In fact, if we divide everything through by -2, we would get an 8t squared minus 45t is equal to 0. Now if we factor out a t, that leaves us 8t minus 45. So do you remember how to solve this? If you solve by factoring, you set each factor equal to 0. You didn't think you were going to use that again, did you? So you get 8t is equal to 45, and then divide through by 8. So t is equal to 45 over 8, or what is that? 5.625. Okay, so that means the rock will hit the ground in 5.6 seconds. Now understand t equals 0, that was initially, right? Initially it was on the ground, it got projected up, and now it's coming back down. Okay. So that concludes this lesson. If you have any questions, please don't hesitate to contact me. Thanks.